Hello and welcome to another video in my LaTeX tutorial series. Today we're going to be talking about some common notation that you would see in calculus, such as limits, integrals, summations, and vector notation. I'm starting with a very basic setup. All LaTeX documents start with the command \document class, and I've set this one up to be 11 point and the type of document is an article. The only package I'll be using for this tutorial is the geometry package, and that is simply to adjust the size of my margins, so that is optional. You don't have to use that. The body of our document will type in between the commands /begin document and /end document. I'm going to begin by identifying the domain and range of a function. The function, and now I want to enter math mode, so I type my $, f of x equals, and in parentheses I want x minus 3 squared, so I raise that to the power 2, plus 1/2, \frac, and TeXmaker is going to fill in the rest of the command when I hit enter. And I can tab to get to the next part and move my cursor outside of the braces. And let's go ahead and compile this and make sure it looks the way we expect. Remember, when you open a new document, you must save it and give it a name before you try and compile it, or you will get a compiling error. Now, I usually hit F1 as a keyboard shortcut to compile my document, but for the sake of the tutorial, I'll probably move my cursor up here and build it by pressing the arrow. That looks good. We have the function f of x equals the quantity x minus 3 squared plus 1/2. So I'm going to continue typing. Has domain. And now to describe the domain, I want to name it with capital D, and I'm going to go into math mode. I want a subscript of f, because it's the domain of function f, a colon, and the domain for this function is all real numbers. Now, we do have the option of using the symbol for all real numbers, but I'm going to use interval notation. So our domain goes from, and we're using, it's an open interval, so parentheses, -infinity. Negative, we're just typing the minus key on the calculator. For the infinity, it's \infty. That's -infinity, comma, and now I want positive infinity, or just infinity, so \infty. Close my parentheses, and let's end math mode and compile that, see what it looks like. Okay, now the one thing I would like to change is the D. I don't want it to be italicized. Because it's in math mode, letters are always going to be italicized. But I can make that not in italics if I come back to my code and I type, basically wrap it with the tag mathrm. So move your cursor in front of the D, \mathrm, and then the curly brackets around the D. Now when we compile it, our D should not be italicized. But the F still is, because it's outside of those curly brackets. So let's finish by describing the range. So the function f of x has domain from -infinity to infinity, and range. So I'm going to do something very similar here. I'm going to use a capital R for the range. So I'm going to go into math mode, but I don't want the R to be in italics, so \mathrm, and in TeXmaker you can see it's trying to complete the command for me. So if I hit enter, it'll type the braces for me, and I can just type my R in the center there, and use the right arrow to come out of the braces. We want the subscript of f, colon, and now our range goes from 1/2 to infinity, and I do want to include the 1/2, so I'm going to use a square bracket around the 1/2. To get the 1/2, I'm using the command for a fraction. Comma, infinity. So backslash infty, open parentheses, close math mode. Now let's typeset that, and I have a feeling I'm not going to be happy with the way it looks. Let's try. Okay, so what I'm not happy about is the square bracket here is not large enough to surround the fraction 1/2. So I explained this in an earlier video on delimiters, but if we want to automatically expand the size of the brackets or braces or parentheses, then we can change the command slightly. So I need to find where that bracket is. So right here I'm going to put my cursor in front of it, and I'm going to type /left, and that is going to automatically fit that bracket to the size of what comes after it. And then the parentheses on the right, I also want to insert my cursor just before it and type /right. So if you use the /left, then you have to balance it somewhere with a /right. The compiler will be looking for that. Okay, so now we can see that both of those delimiters have expanded. The other thing I might want to do, notice that the 1/2 is smaller than the 3. This has shrunk it to fit neatly on a line because it's in line. If we wanted that to display at full size, we could go back and use the display style command. This doesn't bother me. I think it looks good the way it is, so we'll see how to use the display style in another example here in a moment. Let's move on and look at how we can type a limit. And I'm going to go ahead and end this with 2 backslashes to give myself some more space. And to type a limit, the basic command in math mode is \lim. If I just end math mode here and compile, you can see all we get is lim, and even though we're in math mode, these letters are not in italics because the compiler understands that this is a special string of letters. Now we want to adjust this. We want to take the limit of something, and we want to take the limit, let's say we want to take the limit as x approaches a. I'm going to use another command, \limits. And that is going to be followed by, I'm trying to get as x approaches a. So underscore, and then in curly brackets, I want to type x and then an arrow and then a. So the symbol to get that right arrow is \2, T-O, a. And I'm going to close my curly brackets, and now we should see when we compile it the limit as x approaches a. Okay. If I did not use this limits, take that out and recompile, as x approaches a will not be underneath the lim, it will still be a subscript because we used that underline, but it's going to appear to the right, which you may want. I don't like it like that, so I'm going to go ahead and put the \limits command in front, and now the x approaches a will be underneath the word limit. If I want to take the limit, and we have to take the limit of something, so let's come back and add our function. In general, let's just call it f of x. So we want the limit as x approaches a of f of x. If I want to take the left-hand limit, the limit as x approaches a from the left, I just come back to my code, and after the a, use the caret. You can type a plus if you want to approach from the right-hand side. If I want to approach from the left-hand side, I'll type a minus. Okay, let's do one more example with limits. We want the limit, so \lim, and to make the notation look a bit nicer, I'm going to use \limits underscore, And I want, again, just the limit as x approaches a. So in my curly brackets, x backslash 2, to, the limit as x approaches a. Close my curly brackets. And this time I'm going to use the definition of derivative at a point. So the limit as x approaches a of, now I want the fraction f of x minus f of a over x minus a. So backslash frac in my numerator, that's the first set of curly braces or curly brackets. We're going to type f of x minus f of a. In the denominator, so this goes in the second pair of the curly brackets, x minus a. And that, let's come outside of the brackets there, is equal to f prime of a. So f, and I'm just hitting the apostrophe for that prime symbol, of a. Close my math mode. Let's compile this and see how it looks. Alright, I forgot to end my line with 2 backslashes. That'll give me a little bit more space in between there. Now this looks good, but the fraction is displaying rather small, and that's because it's trying to fit it nicely in with the line. But I want to make it look normal size. So I'm going to come back to my command and wrap the entire thing with display style. Backslash, display style, curly bracket, and then at the very end, before I exit math mode, put the closing curly bracket. And let's compile this again. Okay, so now the fraction looks much larger. Same size as the rest of the notation. And that line with 2 backslashes. And now let's look at how to typeset an integral. In math mode, we're going to start with backslash int for integral. Let's take the integral of sine of x. Now if I just type sin, when I compile that, it's going to be italicized. I don't want that. So for sine, cosine, tangent, all the trig functions, we do backslash first. So backslash sin of x, and that should give me the integral of sine x. Now I also need my dx. I can type dx just like this, close math mode. Let's see what that looks like. Now notice that the x and the dx are kind of look like they're running together there. So what I like to do here is just force a space to be inserted between those. Because remember, just because you type a space over here in the code doesn't mean it's going to appear as a space when you compile your document. But to force a space right there, I'm going to hit backslash, comma. So let's compile that and see if it makes a difference. Okay, good. So now there is a space between my x and my dx. Now if you don't want the d italicized, we saw, as we did when we were typing domain and range, how we can wrap that lowercase d with the backslash math rm tag, and it wouldn't be italicized. But the italics don't bother me with the dx, so I'm going to leave it like that. Well, let's go ahead and solve this integral. So the integral of sine x dx equals negative cosine x, so I'm going to do backslash cosine x. Now let's talk about spacing for a moment. Over here I left a space in between or in front of this slash sign. That's optional. I didn't over here, but I did leave a space between the s and the x here. Otherwise the compiler might get confused and think your command is backslash cos x all as one thing. So we want to separate that with a space. And let's not forget r plus c, very important. And we'll compile that. And there we go. If I want my integral sign to be longer, so when you see it in a textbook, you see it online, usually it doesn't look that short. And it's shrunk here to kind of make it fit in that line neatly. But we can expand that simply by using display style. So backslash display style, curly bracket, and then just before we end math mode, put the closing curly bracket. And that elongated that integral symbol. Next, let's look at a definite integral. So we also start with backslash int, that's the command for integral. But this time we need to show that we want to take the integral from a to b. Now I can simply use an underscore and type a caret b. Let me close math mode and see what that looks like. Okay, so that gives me the short integral, but it is going from a to b, and my lower limit and upper limit of integration appear to the right of the integral symbol. We can also use \int with the \limits command, underscore a caret b. And now we have an integral where the a and the b are not to the right of the integral symbol, but they're above and below the symbol. So you can decide which one of those you prefer. If you want the integral symbol elongated, simply wrap it with display style. I'm going to just copy those last two commands, and we'll see what they look with display style in front. Okay, so we get longer integrals, which sometimes looks nicer. Let's continue working with our definite integral to talk about some problems you may encounter along the way. If one of your limits is more than one character, then just using the caret is not going to be sufficient. So for example, let's say for some reason you wanted to go from 2a to b. Let's see what happens when we compile this. Okay, that's probably not what you were expecting to see. So what we're going to do to fix this is after the underscore, the lower limit, you want to wrap that in braces or curly brackets. And then we can do the same for the upper limit. Now if it's just a single character, it's not going to be a problem. But if you have more than one character, you will need to do that. So just to be on the safe side, you can always use the curly brackets. Then you shouldn't run into any trouble there. So now we have our integral with the lower limit of 2a and the upper limit of b. Let's go back to just a and b. I'm going to keep the braces. Okay, now I'm moving my cursor in front of the last curly bracket because that goes with the display style command. So let's take the integral of something. Let's take the integral of x squared dx. And remember, I want to insert a space. Just typing a space is not going to insert a space when I compile this. So I'm going to use \comma dx. And we'll compile that and make sure it looks good. So we have the integral of x squared dx from a to b. And that is equal to, now there are a couple different notations you might see for evaluating a definite integral. I usually use the square brackets around the expression. So I'm going to type the square bracket for the left side. When we integrate this, the antiderivative for x squared is x cubed over 3. So I could write 1/3 x cubed. I'm just going to go ahead and write x cubed over 3. So I want the fraction x cubed over 3. Because this is a definite integral, we need to input our lower limit and upper limit. So let me end with a square bracket, and then to get my limits on there, I'm going to use the underscore and then lower limit of a caret upper limit of b. So again, if it's a single character, you don't have to wrap it with the curly brackets. But to be on the safe side, we can go ahead and do that, just so you're familiar with the notation. Okay, now let's see what that looks like. Because I have a fraction, I have a feeling I'm not going to be happy with the brackets. Okay, so the lower limit and upper limit do appear in the correct place in relation to the bracket, but the bracket needs to be expanded to the height of the fraction. So I'm going to go back where I typed my opening square bracket, and in front of that, \left. where I typed my closing square bracket, in front of that I type \right. And we'll compile that, and that looks much better. And let's go ahead and finish evaluating our integral here. So that is equal to \fraction b cubed in the numerator over 3 in the denominator. And I need to move my cursor to the right so that I'm outside of that first fraction. And now it's minus, and we plug in our lower limit of a, so I need another fraction, \frac. Our numerator is a to the power 3, denominator 3. Let's compile that. The next thing we're going to look at is summation notation. To get the capital sigma, we're going to use the command \sum. If I compile that, it's going to be pretty short. So usually that is written much larger than the text beside it. So we can make it larger using display style, display style, curly bracket. And we go to the end and put the closing curly bracket. If I compile that, now you can see the size is much larger. We want our sum to go from n equals 1 to infinity. I'm going to use \limits. So I'm going to use then an underscore, and on the bottom I want n equals 1. That's not a single character, so this time I have to use the curly brackets. N equals 1, close the curly brackets, use the caret, and now we're going to type our upper bound. So this time I want to go to infinity. So in the curly brackets, I'm going to type \infty and close the brackets. Let's compile and see what we have there. Okay, so we have the sum from n equals 1 to infinity. And let's keep going with that. I need to be in front of the last curly bracket because that closes the display style. And we want to take, let's see, the sum of, let's do geometric series, a times r to the power n. And that is equal to, let's go ahead and compile so we can see where we are. I'm going to go ahead and expand that sum. So that is equal to a plus a times r plus a times r squared plus, now I want ... plus my nth term, a times r to the power n. Let's compile and see what we have. I have the ... but the ... should be centered vertically so that it's kind of aligned with the horizontal crossbar of the plus sign. And instead of typing ... there's a command for the 3 dots. I don't need to insert space between it, but just to keep the code nice and clean, I will. And that command is /. If you just want a single dot, it's c dot. If you want the 3 dots, put an s at the end, \c dots. So when I compile this, those 3 dots should be vertically centered. For our next command, we're going to put all of this stuff together and give the definition of a Riemann sum using a definite integral. So let's open math mode, and the first thing I want to type is the definite integral of f of x from a to b. So we're going to do display style, open curly brackets. I'm going to go ahead and end them and end the math mode, and then just type in between those brackets. So we're starting with an integral, so \int underscore and then a caret b. My function will just be f of x, and then to insert a space here, \, dx equals. Let's compile, just make sure we don't have any errors to this point, and everything looks the way we expect. Okay, we have the integral from a to b, f of x dx is equal to. Now we want the limit as n approaches infinity, so \lim. I want to use \limits so that the x approaches infinity part appears underneath the lim. So underscore, curly brackets, x, and then to get the arrow, backslash 2, to, infinity, backslash infty, closing curly brackets. So that should say the limit as x goes to infinity. Let's compile. Make sure we're doing everything correctly. That looks good. Put my cursor back in front of the last curly bracket because we still want to be working inside of display style. Now I want the sum as k goes from 1 to n. So backslash sum, backslash limits, underscore, and I want k equals 1 on the bottom, so in curly brackets, k equals 1, close that, caret, on the top I just want n. The curly brackets are optional since it's a single character. So let's make sure we have our sum displaying correctly. Good. Now we want to take the sum of f of x sub k. So x underscore k, and I don't think I need to expand the parentheses. We can see what it looks like when we typeset it, times delta x. Now this is optional, but I'm going to go ahead and put the dot to indicate multiplication. So backslash c dot, that will be a single dot centered vertically, and I'm multiplying that by delta x. Now to get the delta symbol, for those Greek letters, it's backslash and the name of the letter. But if I just type all lowercase delta x, I'm going to get the lowercase Greek letter. So let's see what happens there. Okay, so I've got my f of x sub k. The parentheses look fine. I don't need to expand them. I've got my dot, and that is not what I wanted to see for delta x. So the delta symbol, the triangle, is actually the capital letter in the Greek alphabet. So we're just going to go back, and instead of lowercase d, it's backslash delta with an uppercase d. Let's compile that again, and now I have my delta x. We have one last thing to look at that you might run into in calculus notation, and that is vectors. So to get the vector symbol, it's simply backslash VEC. And then in curly brackets, what you want to put the symbol over. So I'm going to call this vector v. Vector v is equal to, and let's do the ij notation. So we have our first component, v sub 1, times vector I, so backslash VEC, vector I, plus v sub 2, so v underscore 2, times vector j, so backslash VEC and j in the curly brackets. And that is equal to, if we want to write this in component form, I like to use angular brackets. So it would be, for the left angular bracket, it's backslash L angle, and that's going to insert the bracket. So now we need our first component, v sub 1, comma, our second component, v sub 2, and then we want the closing bracket, the right angular bracket, so backslash R angle. And that should do it. Let's close math mode, compile, and see how that looks. And I forgot to put 2 backslashes earlier to give myself a little more vertical spacing. Okay, that looks good. So vector v equals v1 times vector I plus v sub 2 times vector j. We're in component form, just v1 comma v2 in the angular brackets. And that concludes this tutorial on calculus notation.